Welcome back. Now in this video, we're going to speak about Kotlin Coroutine builders and dispatchers. So you're going to understand how to build coroutines that returns a value and when to use which. And also you're going to learn about dispatchers and their role in Kotlin coroutines. So let's get started. There are different ways to create coroutines, but here we'll discuss the main and the common one. So these functions are going to help us bridge between coroutines and non-coroutine world so that we can execute our coroutines. So first we have already seen is a launch. So the launch coroutine builder is used to start a new coroutine that does not actually return a result. So it is used to fire and forget tasks. So tasks that don't need to return a value, actually you can use a launch. Okay, now let's see here at an example of how coroutines launch is going to create a new coroutine. So basically here we have a global scope. So a scope is like an environment that is going to help us to actually create these coroutines and actually control them. So for now, just understand it as that. In future videos, we're going to explain the scopes and their roles in coroutines. So here we have a print function that is going to print, for example, coroutine 1 started and coroutine 2 actually finished, coroutine 1 finished. And here we have a delay function and we have launched multiple coroutines by using a launch builder. And here we're using thread.sleep in order to wait for all of these to actually finish executing. Otherwise else, then our function is not going to return anything because it's going to be cancelled. So we're going to speak about cancellation and other things whenever we're going to speak about this. Now let's try to run here our main function. So let's click here and run and see the output that is going to be printed. So you can see here our coroutines are actually executed. And one thing which you can note is that these are not executed in order because they're going to be launched in parallel. So this coroutine here is going to execute, for example, starting and finishing. So you can see here our first coroutine is actually starting with this second coroutine. Then again, it started with coroutine number 3, which is actually here. So basically the execution of these coroutines are not going to block the execution of other coroutines. So this is one thing which you have to understand. Okay, so using launch here is not going to return a result. So basically it's going to fire and forget. But what if we want to get a result from actually executing this suspendable computation? So basically we have to use another launcher that is called async. This async has a concept of async await. So async is a coroutine builder similar to launch, but it returns some values to the caller. So using the async methods, we can perform an asynchronous task that returns a value. And in Kotlin, this is called actually a deferred value. Okay, so here is an example. You can see we have a printing that we are going to start. And basically, we're going to declare here 2 values. So we have the result that is just, we're going to use a global scope and launch by using async. Now with async here, basically we're going to delay this for 100 milliseconds. Then after that, we're going to return 1. So basically here we can be performing a network request or a suspendable computation that is going to perform mathematical operations or anything else. So for simplicity, let's just return this. And the second one, we have to return 2. Now here we can be doing other works while we are waiting for this to finish executing. Then we can do this by using await. Await is a suspend function, meaning that it needs to be run inside the coroutine scope. That's why we're using here run blocking. And as we have said, this run blocking we have used previously, and we're going to explain this in the next section here. But for now, run blocking here is going to give us a coroutine scope that we can easily execute these 2 functions here. So you can see it's represented with this check mark here inside Android Studio. That means this is a suspend function. Then we can print end here. Now let's try to re-execute here our main function and see. Okay, so you can see here we have printed the start and this is starting here. Then now because these 2 are going to take 100 milliseconds here to be actually executed, then we can proceed doing other works that don't need actually to use this suspendable computation. So for this case, we can wait for them to finish. So here basically we print doing other works. Then we can print these values after we call .await after the result is actually available. Then we can finish up our coroutine by calling end. So this is how you actually return a value from a suspend function. Okay, so now here we have already seen how we can launch a coroutine by using a run blocking. So let's look here at a simple example. So in order to use LAN blocking here, you can just easily declare, for example, LAN blocking. And here we can actually execute because we have a coroutine scope. So right now you can notice we are not going to use a global scope.launch, but basically this one is going to create a scope that we can use to actually execute this. So this is another way which you can use to create a coroutine. So far we have said that coroutines are actually non-blocking asynchronous code. But as the name here, this suggests, sometimes we're going to need to actually run something in a blocking way. So we want, for example, something to first to finish in order to proceed with other things. So this is where we're going to use run blocking. So run blocking is mainly used to write inside test cases. It's going to help you to execute suspending function in a synchronous context, or making it easier to write tests for coroutine-based code. And another case here, you can see we are using this inside our main function, and this one is going to bridge us between the coroutine and non-coroutine way of executing. So for example, inside our main function here, then we can want to execute other coroutines inside here. So we can create this LAN blocking here. And here we have a simple example. So you can see we are printing here that, then we're launching a new coroutine here. Then we can perform other coroutine suspending functions. For example, here a delay inside this run blocking here. As you can see, it's evident here. Otherwise, if we don't have this run blocking, basically we cannot have the access to launch here. So let's try to execute this code here and see the output. Okay, so you can see here it's going to start. Then this waiting for coroutine to complete is going to be executed. Then after the coroutine complete, then we delay here, for example, for 200 seconds. Then we can actually finish by printing here end, because we have finished to execute here our coroutine that we have launched inside a run blocking here. So another use case that is you can use a run blocking, but there are different ways which you can use to solve this problem. But one way of solving this issue, for example, you have a legacy code that is going to use threads. And basically this thread is going to block your coroutines. So you want to bridge this non-coroutine world to a coroutine world. So basically you can use a run blocking to solve this issue. Let me show you an example here. Okay, now let's assume here we have a legacy block of function that is going to use actually threads here, or you can use runnable that is going to have a callback. And this one is going to give us a legacy code actually completed. Now, when we want to execute this inside, for example, main function, let's assume that we did not use here LAN blocking. And basically we can use, for example, another LAN blocking here. We can launch it. Then we can call here a legacy code and print the result, and actually avoiding blocking our main thread. So basically here we can use this, and actually it's going to launch another coroutine, and then it's going to execute this function inside here. So let's try to execute this code, and you can see that it's going to function properly as normal. So you can see here it's starting. Then you can see the legacy code is going to be executed here, and the result is actually printed. Then we have here waiting for coroutine, then coroutine can proceed. And basically this way is going to help us to bridge this. So basically using this LAN blocking here is going to help us to avoid actually freezing the whole UI because of just a simple legacy code that we have. So basically we can use this and block a certain thread pools and actually proceed with our execution. Okay, so when we create a coroutine, basically there is an object that is actually passed. So this object is going to define the behavior of a coroutine, and it's called a coroutine context. So when you look here, inside here launch, we have not specified any type of parameter, but you can see there is this parameter that is called the coroutine context, and by default is given by empty coroutine context. So this coroutine context mainly include three things. So the first thing is a job. So a job is a handle that actually controls a coroutine execution. So we're going to speak more about jobs in later videos. But you can know that a handle that is going to be used to control this coroutine. Another case is a dispatcher, which we'll discuss in this video. So this helps in determining the threads which the coroutine will actually execute. Then we have another case is exception handler, which also we'll discuss in next videos. Now let's create here a coroutine that is actually being called launch. So we can use here run blocking and actually launch here. So we want to see which thread actually we are going to be running because we have used here launch. Now let's try to run here on main KT. So as you can see that the current thread is actually the main when we use a launch without any parameters, so it's going to inherit the context, and thus is the dispatcher from the parent it is being launched from. So in this case, it inherits the context from the main run blocking coroutines, which runs in the main thread. So you can see this run blocking here is actually having its own context. As you can see, it's defining here a coroutine scope. So launch by default, if we don't specify any type of parameter, going to actually inherit this from the line blocking. That's why whenever we print here, the thread is actually being the main thread. So now let's try to specify here a dispatcher. So we can easily specify dispatcher by calling dispatchers object and specifying which one we want. So for a case, let's go with the default. And here, whenever we print the thread, it's going to be different. Now let's assume here and add several functions that we are going to use them. So we are delaying here, we are performing a heavy computation, then we're going to print that heavy computation. Now let's try to execute here. You can see that the current thread now is not main and it's shifted to actually default dispatcher worker 1, which basically this is the child. Now it doesn't inherit from the line blocking. So the default dispatchers which we have used here are very useful for CPU intensive work. So things like data processing, image processing, which are present in memory. And don't confuse here, not fetching or getting data from the disk or network respectively. So performing complex calculation like matrix multiplication, or we want to do some simple filters, sorting of data, or adding image processing, so we can use this dispatcher.default in order to perform those operations. So this is one of the dispatcher. Let's try to use a different dispatcher here. Okay, so these dispatchers cannot be only used by launch. Also, we can use them inside the async. That's why I have used here. So here what we are doing is basically we want to fetch the data from the network. Basically here we are going to fetch this and return the data. And here we are simulating, we are making a network request actually. Then here we await print the data to the console. So for this case, we are using here a dispatcher IO. So the dispatcher IO is optimized for IO modes, operations like reading or writing files in our disk, interacting with databases, or making network requests. So it's different from default. We said that the default is actually based on CPU intensive. Now here we can use these thread pools in order to actually perform heavy tasks like writing inside our disk. Let's try to execute here and see the output. Now again here you can see we are switching to a different thread, and actually now it has used a default dispatcher worker 1. And here you can see we are fetching the data and the result is actually returned. So this is how we use actually to perform network operations. This is using dispatcher IO. Okay, so now let's look at another dispatcher. So this dispatcher is called dispatchers.unconfined. It's a special kind of dispatcher. So you can see here we're going to start from the coroutine, which we're going to print here. So we're going to print the thread which we're going to start from without using any coroutines, any scope. And then we are going to look at the thread that we are going to be inside unconfined whenever we launch this. Then after that, we are going to look after we perform a delay function, which thread are we going to be. So let's try to execute here and see. So our file has finished to execute. You can see first we are starting from the main thread. So we're printing here the start, which is going to be the main thread. Then the coroutine is going to also open up here the scope. Then we are still in the main thread. But after we perform a suspend function, you can see that we are shifting to another thread that is the default executor. So this dispatcher is going to start the coroutine in the current thread. But if it's going to suspend, it will resume in the thread that is determined by the suspending function. So it is not commonly used except in very special cases. And mostly it's used in test cases. So you have to use this with caution because you don't know which thread is going to be executed. So thus you have to use it with caution. We have seen almost 4 dispatchers in use. So what are you going to choose the dispatcher for your job? So we have the dispatcher main. So this one is going to be used for UI related task or main activities task that we are going to be performing. So don't perform network operation or disk operations inside this dispatcher. The next case is we have the dispatcher.io. This one is for network calls, database operation, or reading and writing the files. Another case we have the dispatcher.default. These one are going to be used for CPU intensive tasks like sorting, data processing, and etc. And lastly, we have the dispatcher.unconfined, rarely used, and for tasks that do not need a specific dispatcher, and for example, in test cases. Let's leave it here for this video. If you find this video helpful, please don't forget to provide a like, subscribe, and share this to others so that they can learn more. So in the next video, we're going to speak about coroutine scope. So until next time, see you there. Bye bye for now.